So, sig figs, guys, again, they're all the numbers that can be known precisely plus that last estimated digit. So yesterday when you were doing that ruler activity, okay, and you guys were, stressing out, you couldn't figure out what's different about it, it's how many decimals. To be honest, I have no idea what the length or the width measurements were on your cards. All I was looking at were your numbers, how far you reported your numbers to, because that tells me that you changed it up based on the ruler. Each ruler was different. One measured tens every 10 centimeters, one measured every 1 centimeter, and one was specific enough to 0.1 centimeters. So that last number is the one that you estimated. Maybe you and your partner kept going back and forth on what that last number should have been based on you saw it one way and they saw it a different way. Okay? It's left up to be estimated, but all the other numbers are precisely known. And that's what we're going to see here all the year throughout lab, and especially with all the measurements that we take, and we're going to learn about that. So, I have a map of the United States right here. Okay? So when we start looking at sig figs, and when we always have to keep track of how many we have in each measurement, okay, each number. What are the important numbers? And that's really what we're showing. Yesterday with scientific notation, when we wrote something like this, like a million, okay, are all those numbers important? No. What's the one important number here? 1, right? Because we wrote it as 1 times 10 to the 6th, or whatever. We could call it meters if we wanted to. All right? So that 1 was the only important, the only significant number. That's the only one that we knew accurately based on whatever tool we used to measure. In this case, probably a meter stick or something like that. Okay? The zeros are just placeholders. So sometimes zeros are important numbers, and sometimes they're not. And that's what we got to determine here. So I have a map of the United States. I'm going to test your guys' geography skills here. All right. The first question you want to ask yourself to how to determine how many you have is this. Do I have a decimal? Okay. You're going to look at the number you're given. You're going to ask yourself, do I have a decimal? If I have a decimal, I'm going to start counting from the Pacific side. So when I look at the United States, this is where that ties into it. When I look at it, which side is the Pacific? Don't let me down here. Don't let your other teachers, your geography teachers down here. The left. Good. It's always an up in the air question every time I ask it. So over here is the Pacific, right? Okay. So the Pacific, if the decimal is present, you start counting on the Pacific side. That's what you'll write in above that arrow. If the decimal is present, you start at the Pacific. Now, this is just one way. So this may confuse some of you, and that's okay. Find the way that works for you to remember this. This is the way that I learned it. It's the way I still remember today. What I'm getting at here with present and Pacific, what letters do those start with? P, present Pacific. If it's there, you start from the left side. Okay? On the opposite coast, the coast that we're closer to, what ocean do we have over there? The Atlantic. You probably can think maybe where I'm going with this. Okay? If the decimal is not present, what's another term we could call not present? Absent. Oh, look at that. Absent Atlantic. What letters do those start with? A. Oh my goodness, look at that. So if it's absent or it's not there, we start counting from the right side. And if it's there, if it's present, we start from the left side, the Pacific side. Okay? So keep that in mind. That may help you. Maybe it won't. Maybe you don't even need that. That's fine. Whatever works for you, use that. Now you're probably like, what in the world is he talking about? Left side or right side? Well, we're going to jump into some practice here. That's where you guys will start to see what I mean by that. It's going to click for each one of you at a different time. Okay, so it may take you 4 or 5 examples. You may be somebody who takes you the first time and you see what I'm talking about. It's okay. Okay, we're going to do a lot of practice with this throughout the year. Can I go on to the next slide? Everybody get that down? All right. So here we go. We have some examples here. So I'm going to draw my United States map out here. There's Texas. There's Florida. All right. That looks like the United States, right? You're going to find that... It looks like a what?
That's what I said.
Maybe I should redraw that then. No? Texas is right here. There's a triangle for Texas, all right? You're going to find out that I am not an artist, all right? It's just the way it is. we're going to remove Texas. It's all in there, okay? So, there it is. You guys have that picture already in your notes. Here, I'm going to start over here on the left side. What's the first question you need to ask yourself? Is there a decimal present? There is. So if it's present, what side do we start from? Okay. The Pacific, the left-hand side. So why I'm drawing an arrow, guys, we're going to move away from this at some point. Right now, if it helps you, go ahead and do this. You should do it right now. And eventually you're going to move away from having to draw the arrow. But if you need to all along, keep doing it. It's not going to hurt anything. Okay? So we're going to start from the left side. Now, we start counting numbers that are significant when we get to something other than 0. Okay? Zeros are only important if they are in between other numbers or if they're at the end of the number from where the opposite side you start counting. So here we go. We're going to start from the left side. Is this 0 for my first number? No. So is it important? Absolutely. Okay? Absolutely it is. Zeros, when you start, aren't important. We'll end up crossing out. You'll see what I mean in a second. So we'll start with the number 3. It's a non-zero number. We're going to start counting. Once you start counting, you count every number until you run out. Okay? So this number is important. So there's 1. That number is important. 2, 3. I have 4 sig figs with this first number. Okay? I've got 4 significant figures. Every number in this number is important. Okay? What's that? Yeah, that's what you'll write on the line. And you're going to see me all throughout the year, folks, abbreviate this as SF. Okay, so if you get a quiz or a test or a lab back and it says minus some points, and I just put SF there, that means your sig figs are wrong. Okay? Let's take a look at the second example. All right. What's the first question I need to ask myself? Is there a decimal? Yes. Which side am I going to start from? The left. So, now, here's my first number. Is that a number besides 0? No, so I'm not going to count it. Move on to the next one. Is that a number besides 0? Cross out the zeros at first. Number 2. This is number 2. Is that important? So once you start counting, you count until you run out. So how many sig figs am I going to have here? I've got 3 significant figures here. Why is that? What's another way, guys, that we could write this number to still show the same number of sig figs? Just 3.
3 over 1.
Nope. Not this number.
Oh, that one?
The other number, the decimal. Yeah, go ahead, Ben.
2.35 times 10 to the third.
Absolutely. 2.35 times 10 to the negative third. So, right? Guys, that's what scientific notation is doing. Scientific notation shows you all the significant or important numbers. So anytime you're asked to count the correct number of sig figs in a number that's already written scientifically, in scientific notation, you just count up every number that they gave you, because every number is important. Okay? So that's why, because those zeros are just placeholders, we're not really concerned with those. They're not telling us too much about the measurement. Now they're telling us, yeah, it's a small number, but we could rewrite it like we said in scientific notation, which is how we would do it in this class. You guys try that third one there, 75.620. I want you guys to come up with and count how many sig figs are present. All right, what's our first question we want to ask ourselves? Do we have a decimal?
Yeah.
Which side do we start from? The left side. So we're coming in here. Do I start with this 7?
Yeah.
Absolutely. Who can tell me how many sig figs I have in this number?
5.
5? Why do you say 5, Colton?
Because all of the numbers are important, even the 0.
Why is the 0 important here?
Is at the end.
It's at the end, guys. Zeros are only... Well, hold on. I don't want to say this so it doesn't sound confusing. Zeros are important only when they are in the middle or at the end of the number. If you start with 0, that's when we'll cross those out. Okay, the first one. So we have actually 5 sig figs here. Let's jump over to the right side. Okay, no decimal. So which side are we going to start from? We start right here. So, am I going to count this as first 0? No, it's the first number I come into. Am I going to count the second 0? How many sig figs do I have? I've got 3 sig figs here.
Sick pigs. That's what I keep hearing.
What do you hear?
Sick pigs.
Sick pigs?
Yeah.
Oh no.
Sick pigs.
We don't want to have sick pigs.
No, like,
Sick.
Oh, like they're sick?
Yeah, there's
Is that term coming around again? That was, okay. Moving on to the next one. Do I have a decimal?
Yes.
No, we don't, right? Which side do I start from? The right. Am I going to count that first 0? Am I going to count this 5? This 3? What about the 0? Why? Exactly. Once you start counting, guys, you count every number. All right. And see, now we have 5 sig figs here. And the last one we should have 4. I want you guys to do numbers 1 through 10 right there. That practice. Take a couple minutes and do that on your own. Who can tell me number 1? Colton.
1.
Why?
Because the 2 zeros in front of it are not.
Exactly, guys. We have a decimal, so we're starting from the left. Okay, so that we come to zeros first. They don't matter. They're just placeholders. So 1 is the only number that is significant. Now, if you take a look at 1 and 2, okay, here's what's going on with these numbers. So let's just think about it. Remember, it said, if we go back to it, if we go back a few slides, well, one slide, really. It shows you all the numbers that can be known precisely plus the last estimated digit. So when you see numbers, guys, like this, okay, the last one is estimated. So this is telling us about our instrument that we used to take these measurements. Okay? So just like yesterday with that measurement activity, one ruler measured accurately to the tens place. So you rounded to the ones place. One measured accurately to the ones place. You rounded to the tenths. One went to the tenths, you rounded to the hundredths, and so on. It tells you how accurate or precise your instrument is. So even though these numbers, they look exactly the same, there's a big difference between them. Okay? In the first one, this measured accurately to the tenths place. This last digit was estimated. So now, in number 2, it looks like it's the same, but this is where it accurately measures to, and the 0 here is where it's the estimated digit. So it tells you about that level of accuracy. They look like the exact same number, but they're not. How many sig figs does number 2 have? It has 2, right? We're still going to cross out the zeros out in front because we're starting from the left because that decimal is present. But now both of these numbers are significant. It means we have a greater level of accuracy within our measurement here. Does that make sense? Okay. So however many zeros we have after, or numbers we have after, so this is kind of going what your guys' question was with that decimal point over here in 5 versus 6. One is more accurate than the other, so it does matter. Number 3, how many sig figs do we have as a class? 3. Number 4, same type of thing. In number 3, it measured accurately to the tens place. We estimated this 1. Now in number 4, we measure accurately to the ones place. We're estimating this last digit. How many sig figs do we have in number 4? We have 4. Number 5, do we have a decimal? No. So we start from what side? The right. How many sig figs do I have? 1. Now we throw that decimal point in there, number 6. How many sig figs do I have? So again, by looking at numbers 5 and 6, guys, that decimal does matter. If you see a decimal at the end of a number on a calculation, say on a practice problem, on a quiz, on a test, or even when you're in lab, and when you're looking at a graduated cylinder, and you think that the line of that liquid is right on the line, you cannot just report it as 10. It has to be 10.0, exactly, because that tells you how accurate your tool was that you measured with. Okay? What's that?
So it does matter?
It does matter, yep. So you could not write number 6 is without that decimal because it's telling you that, hey, all these numbers are important, where in number 5, it was just that first one was important. Okay? Number 7, how many sig figs do we have? 6. Number 8, 1. Again, we're starting from the left. We're crossing all these ones out. 9, how many sig figs? Should be 4. We're starting from the left. That first one doesn't matter, but all the other zeros do. Once you start counting, you count until you run out of numbers. And number 10 should be? Any questions with counting sig figs? That's usually not too bad if you see a few examples. Now we're going to start talking about calculations. So you guys have this information already written for you in your notes, but you should highlight or circle and add a few things to it as I go through it. Order of operations comes into play. What's PEMDAS? Absolutely. You guys are familiar with that. What we're interested in really for us in this class is not so much exponents or parentheses. We'll have those, but we're still going to be coming back and doing multiplication and division most of the time. Okay? We do some adding and subtracting. We're going to talk about the adding and subtracting rule first. And I know it's written second on your sheet, but that's okay. I want to get it out of the way first because we're going to do a whole lot more with multiplying and dividing. Okay? But for those few instances where we are adding and subtracting numbers in lab, this is how we know how far to round. So that question was asked, well, how far do we round, Mr. Conine? Well, this is where we come up with that. So from this point on, you have to follow your sig fig rules for rounding. The other time I say, oh, it doesn't matter. Like in your homework last night, I said, hey, it doesn't matter if you go to one decimal, if you round to a whole number. Now it does matter from here on out the rest of the school year. When we add and subtract, what we're going to do is we round our answer to the least number of decimal places of any of the numbers. So with adding and subtracting, we're looking at decimal places. Okay, so here's 3 numbers here. How many decimal places does the first number have? 2. How many does the second number have? 1. How many does the third number have? Okay. So what you would do is you go through, add it all up first. Okay. When you add that up, I believe it's what? 255.507. I don't have the paper in front of me. Okay. Now, this is too many, guys. You can only report a final answer to the least accurate tool you used to measure with. Okay? So I'm going to jot that down. I highly recommend you doing it so as well. When you're adding and subtracting, you can only report your answer to the least accurate instrument used when you're adding and subtracting. So that should go next to the box that's talking about adding and subtracting. So when you go and plug that into your calculator, it's going to give you the answer that I put right there that's on your paper. Okay? But we've got to round to our final answer. So I highly recommend every calculation you do in this class, guys, okay, wait until the very end to round. We're going to have 5, 6-step problems later on in the year. If you round early, it's going to throw your final answer way off to where you might not receive any credit because you're just way off. Okay? Wait to round until the very end. Keep more decimal places than are needed until the very last calculation and then round. So here we go, 255.507. How many decimals should I report to with this problem? 1, right? Because that's this number right here. Only had 1. It was the least accurate of our instruments. Therefore, that's how far we're going to report it to. So how do I round this? It's going to be 255.5 milliliters. And then show that rounding step. Because let's say you get to the very end, you did everything else right, but then you round wrong. I can still give you partial credit. Okay? You still showed me you knew what you were doing. You just missed one little step of it, not the whole process. That's adding and subtracting. That'll be something you probably will forget. And then later at the end of the year, before the Regents exam, we will come back and review it. And you'll be like, oh, yeah, that's right. Multiplying and dividing, this is the one we're going to use most of the time in this class. Okay? And it's slightly different than what we had before. When we multiply and divide, we round to the least number of sig figs. Least number of sig figs of any of the numbers. So how many sig figs does 23.0 have? It's got 3. 432 has 3. And 19 has 2. When you multiply all this together, what do you get for the big number right there? 784. All right, now what's the unit going to be here? Centimeters cubed. We'll talk about that a little bit more tomorrow in lab. Okay, but I can't report my answer like that. So I'm going to go ahead and look at, well, how many sig figs? How many sig figs should I report this to? 2. Okay, well, I need to keep my number intact, so I'm going to go to like the biggest part of it, guys. These 2 are the only ones that I can keep. That means this is the number that I'm going to round. What would this round to for my final answer? Now you got to keep the number the same, right? or as close to the same as possible. So it's going to be 190,000 centimeters cubed. Okay, it's not just 1.9. Now we could write it as 1.9. How would we keep it the same though? It'd be 1.9. Right, you could write it as scientific notation. Okay, when in doubt, guys, and you have to write something to a correct number of sig figs, you can always go back to scientific notation. It's always going to be right because all those numbers that they show you in front of the times 10 are important. They're your significant ones. So 1.9 times 10 to the 1, 2, 3, 4, 5. Let's do a couple examples here together before we go. All right. Let's take a look at the first one here of your next set. Okay. So somebody do the math with their calculator and give me the full number of 1.35 times 2.467. Don't round it, just give me the number.
3,330.45.
You sure?
Yes.
1 times 2? 1.5 times 2? Is that what number you guys have there?
Yeah. 3.33045.
What's my unit going to be? I think you missed a decimal there, Colton. Decimal is going to be meters squared because you're multiplying. Meters squared. All right, so that's obviously, guys, too far. We're never going to have an instrument that goes that many decimal places. How do I round my final answer? My smallest amount of sig figs. Absolutely, because we multiplied. It's the smallest or least amount of sig figs. I've got 3 in my first, and I've got 4 in my second. So how many sig figs should I report to? And that's going to be 3.33 meters squared. So to help you round, you're going to go 1, 2, 3. This is the number that I would use to round, and then I'd report my final answer and box it. Let's jump down here to this problem. 55.46 minus 28.9. Somebody do the math for me. Colton?
24.642857.
What? You sure? How'd you get that many decimals? 26.56 grams. Now, what mathematical operation did I do here, guys? Subtracted. So how do I figure out what to round to? Least amount of decimal places. We added or subtracted, guys. Least amount of decimals. So 55.46 has 2 decimals. Has 1. So we're going to report to how many decimals? 1 decimal here. Because we had 1 decimal with this number, 28.9. My final answer here is going to be 24.7 grams. Oh my goodness. All right, that would be why. Let me make sure I have it right. It's 26 point what? So that's going to be 26 point... Oh my goodness, I can't do math today. 26.6 grams. You guys are going to finish these problems for homework. Do your best. All right, we'll come back and talk through those tomorrow.